within your textbook. And what they're doing is they're letting theta be equal to alpha over 2. And so if we can take any angle and turn it into a division by 2, then we can utilize or output these in order to find its exact value. Now, you'll notice that these have the plus or minus, and we talked about this last time. This depends on the quadrant that you're in, and we're going to see this as we move forward. And so what we're going to do is we're going to be using each of these half angle formulas, and then depending on what quadrant we're in, we'll be able to use the positive or negative of them. Now, tangent does have 3 options that it works with. It does have one similar to just putting your sine over your cosine, but then it goes further and it can simplify it out into these 2. And so all of these are equivalent. It's just where you're trying to end up, or maybe what information you do have is which one you want to pick with these 3. Okay, so we talked about this last time, and then we talked about some techniques on how to do it. Given the tangent of an angle and the quadrant that it is in, find the exact value or trig functions of the half angle. So you're going to draw a triangle. Hope you're not getting tired drawing triangles, because we're going to keep doing that. Determine the correct half angle formula, substitute, and simplify. And so we covered this last time. And we went into this one, and this should be the one where we left off with. And so we'll just go ahead and work through it in case you don't have it. But I think we were able to finish it out last time. So it says, using a half angle formula, find the exact value of a sine function. So we want to find sine of 15 degrees using a half angle formula. So what I want to do is I want to first relate this 15 degrees in order to a half angle to get my alpha and get those values. And so I say, well, that's the equivalent of 30 degrees over 2. So what this shows me is this is going to be that alpha value that I'm going to plug in the whole way as we're working through our half angle formula. Okay. And so if you remember back to if you have back on the previous page, we know that sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha all over 2. That's just our formula there. Then you'll notice that we're going to let our 15 be 30 over 2. So I'm going to say sine of 15 is equal to 30 over 2, which is equal to plus or minus the square root of 1 minus cosine. Now here, notice I had alpha right here, and we decided we're going to call that 30. So if we're doing cosine of alpha, that means we're doing 1 minus cosine of 30 over 2. And so I'm going to keep working this out. So this would be plus or minus the square root of, hopefully that trig circle is coming in handy, and you kind of have one. Just print it out as you work through problems if you don't have it down yet. And so cosine of 30, go to your unit circle, and that is square root of 3 over 2. So this value here comes from your unit circle. Then if I start kind of cleaning this up, this would give me the square root of 1 minus, let's see, if I do my fraction trick, let me put that over 1. You remember the fraction trick from algebra that if you have a over b plus or minus c over d, that you multiply this way and call it AD, plus or minus multiply this way, BC, all over multiply this way, BD. You remember that fraction trick? That's going to come in handy. I'm going to do that here. This is like a 1 over 1. So 1 times 2 gives me 2. Minus, because that's what it is, 1 times square root of 3 gives me square root of 3. All over 1 times 2, which gives me 2. All over this 2 that was already there. Cleaning that up, that ends up giving you the square root of 2 minus the square root of 3. All over these 2's get put together to give you 4. And then when you're square rooting a fraction, it's like square rooting the top and square rooting the bottom. So I end up with the square root of 2 minus the square root of 3. All over square root of 4 is just 2. And that's the answer I'm going to end with. And that is an exact answer. As ugly as that looks, that's an exact value for what sine of 15 degrees is equivalent to. Okay, and that's where we left off last time, right? Okay, so let's go to this next example here. And it says, given that tangent alpha is equal to 8 over 15 and alpha lies in quadrant 3, find the exact value of the following. And we're just going to do sine of alpha over 2. If you check out the book, they do cosine and tangent as well, but I just wanted to do one of them with you. And so here's what we need to first figure out. Okay? Given that tangent of alpha is equal to 8 over 15, I want to draw it out. So I'm going to draw, this is just a coordinate plane. It says that alpha lies in quadrant 3. So here's quadrant 1, 2, and 3. So that means it's going to lie somewhere in here. So here's my alpha. So if I create my triangle, I just go to the closest x-axis. You don't go to the y-axis, you go to the closest x-axis and create your right triangle. And if tangent alpha is equal to 8 over 15, if you do SOHCAHTOA, that means from alpha, your opposite is going to be 8 and your adjacent is going to be 15. Because I'm in quadrant 3, when I drop down like this, it's actually a -8. And when I go to the left like this, it's a -15. But you can see that because tangent is 8 over 15, the -8 over -15, the negatives cancel each other. That's why there's no negatives present here. Everyone with me so far? Okay. So I've kind of got a triangle here. If you go back to your how-to steps, it says draw a triangle using your tangent and what quadrant it lies in. So that being said, if you think about this in terms of degrees, here's 0 degrees, 90 degrees, 180 degrees, 270, 360, right? So we know that alpha is currently between 180 and 270, right? Y'all okay with that? Okay. So if I want to figure this out, I am going to be looking at, I'm trying to find sine of alpha over 2. So let's identify some things, because we know from sine of alpha over 2, I'm going to have to be using cosine of alpha. And so let's kind of figure out some stuff over here before we get going. First of all, we know that tangent of alpha is equal to 8 over 15. So if I want to find sine of alpha, SOHCAHTOA, so that would be opposite over hypotenuse. So we're going to have to figure out our hypotenuse here. Do you remember what triangle this is? 8, 15. Don't remember that one? Okay, so maybe we need to do some more legwork. Let's do -8 squared plus -15 squared to give me c squared. So see, that's 64 plus 225. So it gives you 289. So 17. This triangle happens a lot, this 8, 15, 17. So if I want to do sine of alpha, that's going to be opposite over hypotenuse, so that's -8 over 17. And cosine of alpha would be equal to -15 over 17. And we're probably going to have to use that cosine alpha here in a minute, because remember this formula here? Okay. So let's consider. If I want to do sine of alpha over 2, that's going to be equal to plus or minus the square root of 1 minus cosine alpha over 2. So it's going to be 1 minus cosine of alpha, we found that over here, is -15 over 17. Be careful, there's a negative from the formula and a negative from your ratio over 2. And then 1 minus 15 over 17, that gives me 32 over 17. I'm dividing a fraction here, so I'm going to have to keep it, change it, flip it, keep the top fraction, change its multiplication, and flip the second one. So that gives me 16 over 17. And let's see, the square root of 16 gives me 4 over the square root of 17. Y'all with me? So rationalize that out. That gives us this 4 square roots of 17 over 17. Now, this whole way we had this plus or minus. Now let's consider if sine of alpha of 2 is going to be positive or negative. I want to go back to this right here. Consider this. 180 is between, alpha is between 180 and 270, right? But I want to know what quadrant is alpha over 2, because sine of that I could figure out better knowing what quadrant's in, because remember, sine is your y value. So right now, sine down here is negative. But if I move up here, sine becomes positive because it's your y value. So if I want to know where alpha over 2 lies, what quadrant, I would divide them all by 2, right? Going back to like chapter 1 of college algebra, dividing an inequality here. So this gives me 90 alpha over 2, and 270 divided by 2 is 135. Doesn't this make alpha over 2 now in quadrant 2? So if alpha over 2 is in quadrant 2, remember any point up here is your xy, and sine would be your y. So isn't sine up here positive and your x is negative? So that means over here, I'm just looking at positive 4 square roots of 17 over 17. And it's positive because sine is positive in quadrant 2. And again, this is positive because sine of alpha over 2 is positive in quadrant 2. So this goes back to why we ever even wrote here on our formulas. Why does that plus or minus? Because it's dependent on the quadrant that your alpha over 2 lies in. So for this one, we were able to draw it here, which helped us to get the correct negatives in the right spot. But then if we're looking at alpha over 2, we need to figure out what quadrant it lies in order to get our sine correctly on sine of that half angle. Questions? That make more sense, Abby, second time around there? Good. All right, so to kind of finish up this section, just the very last page of this notes, I'd like to put this summary here at the end so you kind of have a go-to page for all that you can do. You've got your double angle formulas, which you can see we started with 2 theta. Then we went to our reduction formulas, which take us down to theta. And then we cut it down again and looked at our half angle formulas, and these are all dealing with alpha over 2, and these plus or minuses relation to where alpha over 2 lies in your quadrant. Okay, so this would be a good go-to page for, like, as you're working through the 9.3 assignment, to go, okay, what do I have that I can work with? And here's your good go-to page. And that's just the last page of your notes for 9.3. Questions so far? All right, so what we're going to do in 9.4 is, just like what we've been doing in every section, is we're going to be picking up some new formulas. Okay, so here's 9.4. Let me get my new over to 9.4 stuff here. Okay, so what we're going to be looking at in 9.4 is we've looked at, you know, we just looked at the double angle, the reduction angle, and the half angle. We picked up our Pythagorean identities, our reciprocal identities, our quotient identities. We looked at summation identities. We looked at what is cosine of alpha plus beta. You remember those? And what is sine of alpha plus beta? And we added a bunch of stuff. Now we're going to move into some products. And so what we have is we have these 2 formulas here. We learn what is going to be the cosine of alpha times cosine of beta, and it gives us a formula. And you can see that it has some of your summation formulas within them. And then it says, what about if I want to multiply sine times cosine? And so if I want to do sine of alpha times cosine of beta, then again, we get our summation formulas. You see that those summations of sine also appear there. And they go through some proofs in the text on how starting with 2 and then how they ended up with these. But I just wanted to kind of start with what was given and go from there. So there's proofs of how they started with here and got to this point here. But I want to just kind of jump into the examples today. And so it says, how are we going to do this? If we were given a product of cosines, we're going to express it as a sum. So we're going to write the formula for the product cosines, substitute, and then simplify. And so here's what it says here. It says, write the following product of cosines as a sum. So we're just rewriting it as a sum. So this is what we're going to start with, and we're hoping to end up with a summation. So I'm going to go ahead and write it here. I have 2 cosine of 7x over 2, cosine of 3x over 2, and I want to turn this into a summation. Okay, so from up above there that we can't see, I'll just go ahead and write it here. If I'm looking at cosine of alpha, cosine of beta, it's going to be equivalent to 1/2 cosine alpha minus beta plus cosine alpha plus beta. So if you haven't picked up on this yet, it's always good to identify what is your alpha, what is your beta in the beginning so that you can output it in the right spots. And so you can see that this is going to be my alpha and this is going to be my beta. And so what I need to do is I need to now go throughout this right side and enter my alphas and betas, do some arithmetic, and kind of put it all together. And it's always good to just go ahead and write your formula on the page that you're working with, so you're not like looking here, looking over there, kind of going back and forth. Go ahead and write your formula to get you going. Now this 2 is just a coefficient. It's just going to stay out front. So I'm going to have a 2 from what I'm starting with times 1/2 from the formula, cosine of alpha, which we said was 7x over 2, minus beta, which we're saying is 3x over 2, plus cosine of alpha, 7x over 2, plus beta, 3x over 2. And so I would always recommend just straight plugging in. Don't try to simplify anything along the way. Just go ahead and straight plug in whatever you have. Then once you get it all plugged in, start cleaning it up. 2 times 1/2 just gives me a 1. These essentially just cancel each other. Now in here, I'm going to end up with cosine. No need for the brackets now because my coefficients have gone away. 7x minus 3x gives me a 4x over 2, which just is cosine of 2x. Plus, putting these together, 7 plus 3 gives me a cosine of 10x over 2, which reduces to 5x. And so I was able to take this as a product of cosines and now turn it into a sum of cosines. And that was my goal, to just go from a product to a sum. Questions so far? Okay. Let's do another one. And this one says, express the following product as a sum containing only sine or cosine and no products. So what I'm starting with is sine of 4 theta and cosine of 2 theta. So I'm going to start with sine of 4 theta, cosine of 2 theta, and my goal is to just be sum, nothing being multiplied in there. So I'm going to go back to what I just had from the previous page, and I want to remember that sine alpha cosine beta is equal to 1/2 sine of alpha plus beta plus sine of alpha minus beta. Just using that little formula that we just got. You with me? Okay. So we can see that, let's see, we're going to be calling this value alpha. We're going to be calling this one beta as we fill in accordingly. So this is going to be equal to 1/2 from the formula sine alpha. So I'm going to say sine alpha is 4 theta plus beta, which is 2 theta, plus sine of alpha 4 theta minus beta 2 theta. So in this case, don't lose your 1/2. And I'm going to end up with sine of 4 theta and 2 theta give me 6 theta. Plus sine of 4 theta minus 2 theta, that gives me 2 theta. So at this point, I could just leave it like this. If you like, I could distribute that 1/2. But our goal was to create a sum containing only sine or cosine and no products. And I don't have any products of those sines or cosines. Questions so far? So the key with both of those would be correctly identifying your alpha betas and then just your arithmetic from there, that you're able to combine, do your sums, differences, and not lose any coefficients along the way. So you can see that when we started out, we really just had, if I go back here, we've got the multiplication of 2 different cosines, and we've got the mix of a sine and cosine. But what we don't have yet is a sine times a sine. So in this next part, in part 2, we get a nice box. And so here's kind of a good summation of all of our products of sum formulas. Here's our cosine alpha, cosine beta, just like we worked with. Our sine alpha, cosine beta, just like we work with. And then they've got their sine alpha times sine beta and how that comes to be. And you can see that's just like what we're doing with cosine. And then cosine alpha, sine beta, just reversing those, how it's the same there. So they just kind of give you all the possibilities, but it's going to be based off those first 2 that we worked with. So I'm going to do another example with them. Let's look at this one. Write cosine 3 alpha, cosine 5 alpha as a sum or difference. So kind of a little bit different of wording, but still going to be the same process as we were working before. Okay, so if I'm looking at this, I'm going to go back to this previous page here and kind of see if I can put them both on here. I don't think I can. Okay, so if I'm looking at cosine times cosine, I'm going to go ahead and write on here. So cosine alpha, cosine beta would be equal to 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. I've got my formula here. And so you can see that our alpha is going to be our 3 theta and our beta is going to be our 5 theta. So if I'm looking at cosine 3 theta, cosine 5 theta, that's going to be equivalent to 1/2 cosine of 3 alpha minus 5 alpha plus cosine of 3 alpha plus 5 alpha. Cleaning that up, I end up with 1/2 cosine of negative 2 alpha plus cosine of 8 alpha. Now, if you take into consideration on the even and oddness of cosine, you learn that cosine of negative 2 alpha is the same thing as its positive version. So this would actually be equivalent to positive 2. And then we were able to get this down to the point that we were looking at a sum or difference of them. And so this one was just a little bit different in the fact of it takes into consideration the even and oddness of your trig functions and gets rid of that negative within there. But again, same process. Identify your alphas and betas and plug in your formula accordingly. Okay, so we've got our product to sum formula, how we can manipulate products and turn them into sums. And so now we're going to go the other direction. What if we have sums that we want to turn into products? And so we're going to be looking at them here. We have a nice little box here from your text, and it says the sum to product formulas are as follows. You can see that we've got every possible option. We've got the ones where we're adding up our sines. We've got the ones where we're adding up our cosines. And then we've got the subtraction of our sines and the subtraction of our cosines. You can see that they're going to start looking like half angles in here. And again, if you go to your textbook, they'll show you how they assign alpha and beta and use some substitutions to derive these formulas here. But again, I'm not going to spend our time deriving these. We're going to take these as facts, and then we're going to start utilizing them accordingly. And so let's look at this example here. And it says, write the following difference of signs expression as a product. And so what we're going to be doing is we're going to be going from, not sum, we're going to be going from our difference to our product. And so I want to be going to these formulas here. Now notice what we're working with. We're working with a sine minus a sine. And so it's going to be the second formula here. And so I'm going to go ahead and write that right above our example so we kind of have it all on the same page here. So if I'm looking at sine alpha minus sine beta, that would be equal to 2 sine alpha minus beta over 2 cosine alpha minus beta over 2. So this is the formula we're going to be using to go from a difference to a product. Now you can see that if I write my problem underneath here, sine of 4 theta minus sine of 2 theta. Here's my alpha, here's my beta. So I could fill this in. 2 sine of, let's see, alpha 4 theta minus beta 2 theta all over 2. Cosine of alpha 4 theta minus beta 2 theta all over 2. So I would straight plug this thing in before you ever start simplifying anything up, and then go slowly. So this is going to be 2 sine of 4 minus 2, so 2 theta over 2. 2 theta over 2. So it gives me sine theta, cosine theta. So that cleaned up really nice for us. Did I write that down? I knew that looked funny. This should be a positive from my formula. This just gives me a 6 and a 3. So if you like the formula, not like me, make sure you write the formula correctly, because see, I missed this addition sign right here. I was looking at it thinking, wow, that turned out to just 2 sine, cosine? That didn't seem right. So one was subtraction, one was supposed to be addition. So if I'm adding them, it gives me 6. 6 over 2 reduces down to 3. Okay, next one says evaluate. So this one's going to be a little bit different than the previous example. So it says to evaluate cosine of 15 minus cosine of 75. And so what I want to do is I want to take my formula, cosine, let's see, we're going to be doing subtractions of cosine. I'm going to write it correctly this time. So cosine alpha minus cosine beta, that's equal to negative 2 sine of alpha plus beta over 2 sine of alpha minus beta over 2. So I'm going to use this formula, but I'm actually going to end up with a numeric value when I get done with this. Okay. So again, you can see this is going to be my alpha, and this is going to be my beta as I go. So this is going to be equal to negative 2 sine of alpha plus beta, so 15 plus 75 over 2, sine of, let's see, 15 minus 75 over 2. So this gives me negative 2 sine of 15 and 75, that gives me 90. 90 over 2 gives me 45 degrees. 15 minus 75 gives me negative 60. Negative 60 over 2 gives me negative 30 degrees. Now, if you think about your trig circle, sine of 45 is just square root of 2 over 2. sine of negative 30 is negative 1/2. And then let's see, the negative 2 is going to cancel with this 2 and this negative. So this gives me square root of 2 over 2. So this one was a little bit different. It still executed the formula that we were working with, but it actually gave us down to a numeric value because they were wanting us to evaluate. We weren't just being very generic with thetas and x's and going from there. And so again, here's your unit circle. Okay, I've got one more, and I think we can finish this one up and actually get through 9.4 today too. And so that means what I will work with you on Wednesday is we can work on any questions we have over 9.1 through 9.4. So that'll be really good with our time together here. Okay, this last one here says verifying the identity using double angle formulas and reciprocal identities. And so what it wants us to do is verify that cosecant squared theta minus 2 is equal to this. And so as we work together with these, we're going to kind of be pulling quite a few identities together. And so what I'm going to do is I'm going to start with this right side and move over here to the left. And so the first thing I'm going to do is I'm going to say, okay, I'm working with cosine of 2 theta over sine squared theta. And so I'm going to first make a substitution for the top. We know from the previous section that cosine of 2 theta is equal to 1 minus 2 sine squared theta. And I'm just going to leave the bottom the way it is. Now I'm going to separate this out. Instead of saying 1 minus 2 sine squared theta, I'm going to do 1 over the sine squared and the 2 sine squared over sine squared. So separate out these fractions. So this would be 1 over sine squared theta minus 2 sine squared theta over sine squared theta. So I just separated this into 2 fractions of subtraction. You with me? Cleaning this up, this gives me 1 over sine squared gives me a cosecant squared minus these cancel 2, and that's what I was trying to achieve. So here's just kind of a problem, kind of pulling everything together, and this goes back into 9.3. It works with our double angle on the top there, also works with your reciprocal identity, and kind of finishes up all of 9.4. And so to kind of summarize and end it, ooh, perfect timing in here. To kind of end it up with your summary here, at the very end of your notes, I went ahead and threw in just one big go-to spot here. This has your product to sum formulas, your sum to product formulas. And so if you'll notice at the end of all these notes, I put the summary. Those summary pages will be good go-tos for like what identities or foundational building blocks do I have, and can I